water falling from height 50-meter high fall is to be used for generating electric energy. If 1.8 into 10 to the power 5 kg of water falls per hour and half of the gravitational potential energy can be converted into electrical energy, how many 100-watt lamp can be lit? Okay, so water is falling. Suppose this is the waterfall. The water is falling from height 50 meter. So water is falling from height 50 meter. Okay, water is falling from height 50 meter. So at what rate it is losing the potential energy? So du by dt is how much? Is it mgh is the potential energy, so we can write g and h are constant. H is given and g is fixed. Dm by dt, because per second some mass is coming down. Okay, so this is the rate of decrease of potential energy. This is the rate of change of potential energy. Whatever is the potential energy decreasing, that is being converted through a turbine. Suppose we have a turbine here. Okay, so that turbine is used here to convert this power, this loss of energy into electrical power. So half of this loss is being converted into electrical power. So power electrical. This is loss of what? Which energy? The potential energy. Okay, so the electrical power generated will be half of this thing, because it is writing half of the gravitational potential energy. Okay, so half of, we will take just both because this is decrease of potential energy, so that here we will come with only magnitude part, dm by dt. So this is the power generation rate, electrical power generation rate. Okay, so that is half into h is 50 into g is 10 and dm by dt is how much? 1.8 into the power 5. So this much we are getting. Okay, so this is 0.9 and this will get us 540. 500 into 0.5, 450. 450 into 10 to the power 5 watt. Okay, and how many 100-watt lamps can be lit? So one lamp has 100 watt. So number of lamps lit will be how much? The power generated divided by 100 watt, because one bulb takes the 100-watt power. So 450 into 10 to the power 5 divided by 100. Okay, so how much we are going to get? So we will have 4 5 0 into 3 zeros 2 3. So these many bulbs. So 50 meter height into 10, dm by dt is 1.8 into the power 5 to half. Okay, so this much we are getting. So these many bulbs. Okay, so now you can see that rating of a bulb was how much? 100 watts. So this is the old book. So in old times means 20-30 years back, the bulb which was used generally, which can give a sufficient light in a room, was having power 100 watt. But nowadays you can see the LED bulb. This is about filament bulb. Nowadays you can see LED bulb that means even 9-watt bulb is sufficient for a room. So you can see how much power is being saved nowadays. And in old times, the most of the energy was consumed in for lighting the rooms. Okay, but now the lighting takes very small amount of energy.